Hi, so I'm gonna go ahead and support you guys with question number 3 and 4. And to be very honest with you guys, you have done question number 3 and 4 with me in class, and the only difference is that it's using the word constant of proportionality, which means it's basically talking about the unit rate. So, anyways, let's redo the problems that we did in class just really quickly. Let me go up. And let me actually start with the simple one because I want to keep the video short. Okay, so go ahead and read this problem to yourself, and I'll be with you very shortly. Okay, once you read the problem, I want to ask you, what is this? What's the problem about? What is it talking about? Go ahead and write that down on a piece of paper and then respond to me. So my question was, what is this problem about? Go ahead and respond. Okay, I hope you were able to respond that this problem is basically about giant sequoia, a giant sequoia, which is basically a tree in California. Um, And okay, that's great. Now I'm gonna ask you, what do we know about the giant sequoia? What information is given? Go ahead and write it on your piece of paper and then verbalize when you're ready. Okay, that should have been enough time. What do we know about the giant sequoia? What's given about it? What information is given? All right, I hope you were able to identify that the information given is that it's growing 5.5 feet every half a year. Great. Now my next question to you is, what is the question asking you to find? If you need to reread it, go ahead and reread it. Okay, go ahead and respond. What is the question asking you to find? Great. I hope you were able to tell me that it's asking you to find the growth unit rate, or basically the constant of proportionality, the letter K, for feet per 1 year. That's what's asking you to find. Anyways, let's use the information given to construct a rate. And the rate that you should be able to construct is 5.5 feet. I'm abbreviating feet over half a year. All right. As always, step one is to look at what you have, numerator and denominator. So, and basically in the numerator, do we have just numbers by themselves? And you should respond no, right? Do we have numbers with decimals? Well, should respond no. It's the same situation for the denominator. So what we have to do is we kind of have to take care of our mixed fraction and our fraction by changing them to either decimals or numbers with decimals. So for the mixed fraction, you should know by now that you can split it up into an addition problem, and it's 5 plus 1/2 over 1/2. Now you should know that 1/2 is basically a decimal, and you could convert it. So go ahead and convert it, and it will become 5 plus the decimal version of 1/2, which is 0.5. And for the bottom number, which is a fraction of 1/2, that can be changed to a decimal as well. So once you use your calculator and you add those numbers up for the numerator, you should get the following information. You should get 5.5 over, and the denominator is now 0.5. When you plug this in your calculator now, you should get the following answer. And actually go ahead and plug it in and pause the video of you if I'm going too fast. And you should get 11 feet for 1 year. And we put the 1 under it. You should just get 11 in your calculator, but I'm putting the 1 under it so it can make sense, so you could read it more precisely, because now it tells you 11 feet for 1 year. That's how much this tree is growing. With that information, we're going to construct the table. We know that in 1 year, it's growing 11 feet. That's why I put an 11 over here. The way a table is constructed is basically using the fraction. Just imagine someone tipping over this fraction. Just imagine someone running and tipping it over to the point that the 11 falls over here with the bar. So it's 11. That's all what basically that's essentially what a table does. It just keeps your fractions organized in a different form. All right, great. With the constant proportionality or the unit rate, we're going to construct our table. We know in year 0 and year 1, day 1, we should know how much a tree is growing. It's not growing at all because you planted the seed. Now in year 1, how many feet did it grow? Well, the constant proportionality is telling you it grew 11 feet. Now in year 2, how many feet did it grow? You could definitely use addition here, but I don't want that. I want you to be able to use the constant proportionality, also known as a unit rate. So in 2 years, how can we use that to find out the information for 2 years? Well, it's basically changing this constant proportionality to a rate, and we do that by multiplying. We're gonna multiply by the number we are interested in, and that's 2 years. So we will get information of that, and we find out it's 22 feet for 2 years. And I'm just gonna write the number 22 in there because y is the top. Okay, great. What if I want to know about 3 years? Well, now I have to go back to my constant proportionality and I have to multiply it by a different number. I have to multiply it by the number 3 because I want to find out about 3 years. And it turns out we have 33 feet for the 3rd year. And you repeat the same process for the number 4, and essentially you constructed your table. For one of your problems, you have to find the unit rate first before you start constructing your table. And then on the other problem, you're already given the unit rate. You just use it. Anyways, I hope this summarizes what to do in your problems. I'll see you guys later.